Okay, welcome wonderful chemistry students to another lesson here. Today we're going to just continue on with doing a blend of type 1 ionic, type 2 ionic, and molecular compounds. However, though, we are going to add to molecular compounds. We're going to add a different type of molecule. And this molecule will not have a prefix in the name. And so what you can see here is that there are 7 diatomics listed: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so each of those have a 2 in their formula. And you can see in the picture that there's 2 of each type of atom in here: 2 hydrogen, 2 nitrogen, 2 oxygen, 2 fluorine, 2 chlorine, 2 bromine, and 2 iodine. And actually, if we remember our prefixes, diatomic molecules, di means 2, right? Di means 2. So there are 2 in each of these. And this is something you just kind of have to memorize. When you see 2 atoms that, or when you see a hydrogen listed or a nitrogen listed all by itself, then you know that you are going to give the formula with a 2. So for instance, if I say I have hydrogen, and then I'm going to put H2. If I say I have hydrogen chloride, well, that doesn't apply now because that's another compound. But if I say I have hydrogen by itself, that is H2. And if I say nitrogen by itself, that's N2, or oxygen, that's O2. And notice these have INEs, or they are just the name: hydrogen, nitrogen. If we refer to nitrogen in an ionic compound, or even as in a molecule, we would say ide, nitride, or oxide. Here that retains its name, but it's going to have a 2 with it. All right, because it exists as a diatomic molecule, a 2-atom molecule. So we're going to do an example problem with that here in a second. Also, we must remember when we have a molecular compound, you can identify those by prefixes. So let's not forget that, and we're going to use that today as well. Also, we're going to remember ionic compounds. And so ionic compounds, there were 2 types. One in which we use cations that have only one possible charge. And this is what we see in groups 1, groups 2, and group 3A, right? But we also talked about type 2 cations in which there's more than one charge. And you kind of see this here in the middle section, right? Or where we see the transition metals. And if we see that a cation can have more than one charge, we must put the charge in its name. So for instance, iron 3 means iron with a +3 charge. And iron 2 means iron with a +2 charge. It has nothing to do with the number of iron that you have. It has to do with the charge of the iron, okay? And so when you see anything with a parentheses, know that that is going to be in an ionic compound. So let's do a couple examples today. And then we also did some with polyatomics the other day, right? So make sure we're familiar with our polyatomics. And on our polyatomics, what you're looking for today is just the charge. Next week, I'm going to be giving you the polyatomics, and you're going to have to write the formula and the charge. So, but today is a little bit easier. You can identify polyatomic ions by the ending of their name: ate and ite. Ate and ite. So if you see an ending with ate or ite, then you know you should probably be looking at this polyatomic ion list. Okay, so let's do a couple examples. And we'll start here on video example number 10. You're not going to do this one. What is the formula for chlorine gas? Now, do you notice this says just chlorine? Chlorine, no chlorine with something else, just chlorine. And when we see that phenomenon, when we see that name, I don't know if it's a phenomenon, but when we see that name, we know that this is going to be a diatomic molecule. Also, chlorine is a diatomic molecule. So go look at this up here, and we find chlorine is a diatomic molecule. So it's not true for every element that when it's just its name, but it is true for diatomic molecules. That's why you have to be familiar with these and you have to know them. So chlorine is one of our diatomic molecules. Look what its formula is: Cl2, because di means two atom molecule. It's a two atom molecule. There's two atoms in this molecule and they're both chlorine. So Cl2. So we know the formula for chlorine is Cl2. And so what we're going to do in the show your work, so we identified this compound as being diatomic. We're going to write diatomic in here, but we're also going to make sure that we show the proper subscript. And it should show that there are two. So make sure in your answer you show that. And then you're going to simply write diatomic. So if you do not put the two to show that there are two chlorine, you will get this marked incorrect. You must show that it is Cl2 or whatever element I give you. If it's a diatomic, make sure that you show that. Okay. There we go. That one is done. Oh, and then all we have to do is write the formula gotta make sure we answer it. Cl, and then we'll put A2. So just because you get this right or marked green doesn't mean you're going to end up with full points. The show your work is worth a lot of points. So make sure you're doing the show your work section because I do look at those. Okay, the next part, number 11. What is the formula for carbon tetrachloride? Carbon tetrachloride. We have to, is this ionic? Is it molecular? Is it a diatomic? Well, it's clearly not a diatomic because it has more than one thing. It's carbon and chloride, right? So is it ionic or molecular? And you should be able to see that this has this prefix tetra. And when you see a prefix, you know that is a molecule. And so molecules, all you have to do is write the meaning of the prefix under each element. You do not show charges for molecules. Molecules are not made up of ions. Therefore, they will not have charges. Everything you need to know is in the name. Now, when you see there is no prefix on the first element, that means there is one. When there is, but you see this prefix on the second one, that's identifying it as a molecule. So what do you do in the show your work? What you're going to do, because carbon doesn't have a prefix, I want you to put no prefix, and I want you to say equals 1. And chlorine has the prefix tetra. Go look at your chart and find what tetra means, and you'll see that tetra is equal to 4. All right, so go find that on the molecule prefix chart. All right, and that's all you have to do there, and then type in your answer. You said carbon, no prefix equals 1, so that means there's 1 carbon. And then chlorine, tetra equals 4, Cl. And then you're going to put a subscript of 4. And then you're done there. And that one is easy. All right, and then on the last example, it says, what is the formula for copper 2 nitrate? This is a real easy to identify as ionic. Anytime you have a type 2 ionic, meaning the charge is in the name, you ought to know that's ionic. All right, anytime you see copper 1, copper 2, tin 1, tin 2, all of those, make sure you know that they're ionic. So you do have to look at the charge, and the charge is so important, they put it in the name. All right, that's not true for type 1s, but it is definitely true for type 2. Also, we don't see any prefixes, so there's no prefixes here. This one also contains a polyatomic, nitrate. Notice the ATE ending. So we're going to need to figure out what is the charge of copper 2 and what is the charge of nitrate. So you should already know the charge of copper 2. What does the 2 tell you in the parentheses? Tells you the charge. So we can go up here and we can take a look though and make sure. If you're not sure, find copper 2, and look, it has a +2 charge. Way too easy. And then we're going to go to our polyatomic ion and notice ATE, nitrate. All right, we know it's coming from polyatomic because of the ATE ending. If I said nitride, that means I would go to the periodic table and it would just be nitrogen. But it says nitrate, all right, so it's NO3. And right now I'm giving you the formula. All you need to do is look up the charge, and it's -1. So now we know the charge of our copper and our nitrate, and we're going to put that in our work. So the copper was +2 because it's copper 2. And then nitrate, we looked it up and we said it is a -1. All right, and so we'll put in -1. We'll move that over here. Now, it's very important for you to recognize when you add 2 plus -1, does that equal 0? No. And so we have to make sure the sum of our charges equals 0 when we have an ionic compound. And so the best way to do that is to use the cross technique. Now, when you have a polyatomic, it is incredibly important that you just go ahead and put a parentheses around it. All right, just go ahead and put a parentheses around it. You can be wrong for not having a parentheses. You can't be wrong for having one. So if you see that you have a polyatomic, and this is obvious that you have a polyatomic with when I give you the formula, look, it's a mini atom ion, an ion made up of many atoms. That's what polyatomic means. This is actually made up of 4 different atoms, and it's an ion. All right, and so here we'll move this one over here to this side, and you can do that however you do it. I just like to move stuff once I make it. And there we go. Now we can do the cross technique, but you have to have that parentheses. It's going to make a difference in your counting. So we have a -1. So we're going to say that we need 1, not -1 copper, but 1. And then we are going to take this +2, and we're going to move it outside of the bracket, outside of the parentheses, and we're going to say that we have 2. All right. So we're not bringing the charge down here. We're just showing that we need a number here. And what we're doing is we're evening up the charges. So for instance, and you don't have to show this step. I'm actually going to erase it before I end this. But let's use this dark purple. If you take 1 times +2, you will get +2. If you take 2 times -1, you get -2. And so do you see when you have 2 plus -2, that gives you 0, right? 2 plus -2 gives you 0. You don't need to show that step, but that's the rationale behind that. Okay, there we go. So now all we have to do is write our formula, and it should match our picture. So in our picture, we have a copper. We only have 1 copper, and we do not use subscripts. We have our nitrate in parentheses. So we're going to put NO3 in parentheses. And then outside of the parentheses, we have a subscripted 2. So we'll hit a subscript 2. And that will get you a correct answer on those. So if you have more than 1 polyatomic, make sure you use a parentheses. Even if you don't, you're not wrong for using a parentheses. So anytime you see a polyatomic, use the parentheses. All right, I hope that helps you get your work done today. And I hope you have a really great weekend. And I look forward to seeing you on Monday. We will be meeting virtual. And then A students will be with us on Tuesday, and B students on Wednesday, A students on Thursday, B students on Friday. Can't wait to see you in person. And I look forward to having a sense of normalcy as far as school is related. All right, guys, thank you. If you have any questions, email me. I'll also be watching as you do these live.